Okay, hi everyone. Welcome to the part 5. Whoa! My OneNote just quit. Give me a second, see if this loads back up here. All right, perfect. Welcome to the part 5 homework review. So this is all about target 17, right? And it's linked with what we talked about in part 5 of notes. I know that was a pretty long section. I made 3 videos for it. But it's just really important. And so I wanted to take my time explaining things, especially during this time where I don't get to see you guys in person. And so hopefully that was helpful. Hopefully you put a little bit of practice in. And now, just to remind you a couple of those, skills that we were talking about, and just to remind you about the idea here of sine, cosine, tangent, let's go over a couple of our homework problems. So we're going to talk about problem 1A, 3B, and 5 in this section. And again, it all corresponds to the part 5 worksheet. And so here we go. 1A says find the ratio for the sine, cosine, and tangent of the acute angles of the triangle. Remember, the reason it says acute angles, and that's going to be R and S, T is a right angle, and remember, we never want to use the 90-degree angle as we make these ratios, which is a fraction for our sine, cosine, and tangent. Remember, we can remember how to set up a fraction for these different trig functions using SOHCAHTOA, right? Sine, opposite, and hypotenuse. Cosine, adjacent hypotenuse. Tangent, opposite, adjacent. All right, so let's do this. And I selected these problems on purpose, obviously. So let's talk about cosine of S. So if we find angle S here, let's label opposite, which is across the triangle. Let's label hypotenuse, which is across from the 90. And let's label adjacent, which is right next to the angle we're talking about. And it helps form that angle, right? All right, now for us to find cosine of S, we need to work with the cosine function. That's the c part of SOHCAHTOA, and it tells us adjacent over hypotenuse. So we need the adjacent side and the hypotenuse side. And so we just simply set up a fraction, and it's 45 divided by 53. All right, now for the next one, it wants sine, but this time it says angle R. So we have to flip angles. So I'm going to clear everything I wrote over here. And the reason is when I flip angles, my opposite and my adjacent changes. Now across from R is 45, and that's the opposite side. Hypotenuse stays the same because it's always across from the 90, but now my 28 is my connected side, it's my adjacent side. And so I want sine, so sine is the part of SOHCAHTOA, and we're talking opposite over hypotenuse. So opposite from R is 45, hypotenuse is 53. So it's just 45 over 53. And just this quick reminder that when we change angles, opposite and adjacent flip, and so the cosine of one angle is always equal to the same thing as the sine of the other angle. All right, now let's practice using this stuff. So a lot of times we'll set up these ratios like we did up here, but there will be an X or a Y or a S or a R like in this problem in our fraction. And we got to solve for that. And that'll be a missing side length. So here we go. Remember, every time we do this, we pick the angle they give us, right? Not the 90, but one of the other ones. And then we label opposite, which is across. We label hypotenuse, which is across from the 90, and then the adjacent or connected side. And so if we want to find S, I'm going to do S. Obviously, we need S, but then we also need to use the other side that's a number. So that would be S and 4, which means for us to find S, we need to use opposite and adjacent. That is the TOA part, right? Tangent is opposite over adjacent. So we'll do tangent of our angle. So tan of 36, and that's going to equal opposite over adjacent. So opposite is S, adjacent is 4. And so now we need to solve for S, and we do that by multiplying by what's in the bottom of the fraction, which is just 4. Remember, we multiplied both sides by 4. These 4's cancel, leaving us with just S on the right side, which is great. That's what we want. And that'll equal 4 times the tangent of 36. And so we type 4 times the tangent of 36 into our calculator. I will show you that here. Remember, be in degree mode, and then it's just 4 times tangent and then the angle 36 goes in the parentheses. We hit equals, and it is 2.9. We get 2.9 for S. And so we'll say S equals 2.9. And I can also write that over in this blank. All right, now let's do R. So if we want R, and I'll change the color now. If we want R, obviously we need to use R, but then we still need to use the number we know, right, which is 4. So now we're going to use hypotenuse and adjacent. Adjacent and hypotenuse. I'm going to do that off to the side now. And so adjacent and hypotenuse would be the part, right? Cosine is adjacent over hypotenuse. So we'll do the cosine of our angle, 36, and that'll equal adjacent over hypotenuse. So adjacent is 4, hypotenuse is R. So we do the same thing here. We're going to multiply by the bottom of the fraction. Let me change the color for this. But when we multiply both sides by R, which is the bottom of the fraction, the R's on the right still cancel, but it equals 4. And we still have this R on the left side. And again, we need R by itself. So to get R by itself, now we want to divide by the cosine of 36. Remember to do it to both sides. And remember, cosine, sine, tangent, they're all just numbers. And so it's like we're just dividing by some number, and they cancel each other out. And so R will equal 4 divided by cosine of 36. And we'll type that into our calculator. And R divided, so 4 divided by cosine of 36. 4 divided by cosine 36. It equals, and we get 4.9. 4.9. And so we can write that down. And that can also go on the blank up here. All right, and so that I picked that one so you could get a sense of what about multiplying in one step and we're done. That's what happened over here in S. And then sometimes the variable can be in the bottom, like over here, and it requires us to divide. And so that's the only two types of algebra that'll come out of these problems. And so let's try to feel comfortable with that. All right, now this is an angle of elevation or depression problem because it's a word problem, but they give us a nice picture to go about this. And so I'm going to use the picture since it's already drawn, and we'll be able to solve this thing. So we want to find the distance from a house on shore to a house on the island. So that's what D is in this picture. We want to know what D is. And to do that, a surveyor measures from the house on shore, so that's over here, to a point B. They know that this distance right here is 40 meters. And then they use some kind of tool, it's called a transit, and they figure out that the angle from point B to the other house is 42 degrees. So now let's use this because we've created a triangle, and let's figure out what D is. So pick our angle, figure out opposite, adjacent, and hypotenuse. So D is opposite. Hypotenuse is across from our 90. Doesn't matter in this problem because there's no information on it, which means 40 is the connected or adjacent side. So we're going to use opposite and adjacent in this problem. That is TOA. And so tangent of our angle, tangent of 42, equals opposite over adjacent. So D over 40. And that's nice. We just multiply both sides by the bottom of our fraction, right? So we're multiplying both sides by 40. These 40s cancel, and it leaves us just with D, which is what we want. And so what we'll type into our calculator is 40 times the tangent of 42. Let's do that real quick. 40 times the tangent of 42. Be in degree mode. 40 times tangent of 42, close the parentheses, equals 36.0. 36.0. And so let's write that down. And then remember, there are units in this problem. If you look at the picture, they tell us meters. So this is 36.0 meters. And so what we did here was we found out that the distance from the house on the shore to the house on the island is 36.0 meters. And we use sine, cosine, tangent to figure that out. All right, great work. There's one more section left of this note packet. It definitely revolves around sine, cosine, or tangent. It's going to take a little bit of a different kind of process, though. In the next section, we're going to start solving for angle measures instead. But we'll use sine, cosine, and tangent to do that as well. And then we can solve for like everything that's missing in a right triangle, which is a great skill to have. So thank you very much. Keep working hard. Talk to you tomorrow.